right, good afternoon, everybody. Um, um, uh, we are Project Kganya, and I'm pretty much sure that you guys are happy to hear what the last group. Okay, so my name is Mufumi Rikoto, and this is Mangaliso Mguni. As part of Project Kganya, well, basically Kganya means light, and you will find out why in just a few seconds. So basically, our project entails using our XRT images, X-ray transmission images. What these images do is basically they can pick out particles of interest from background of waste, and basically these images are used in sorting. So you'd find that something like conveyor belts uses this um, image to sort out particular particles on the conveyor belt that would be required. And during the process, what happens is that particles clump up or just come together in like a particle, and what happens is that this degrades the performance of the sorting. So we are basically going to use the data analytics process to find an intuitive method in which we can address that problem. So we are going through that whole process. So the objectives of our project was to identify the clumps in the image. So in a few seconds you'll see the image. It has certain particles. Our task is to identify the clumps. And then the secondary task is to detect the number of particles in a clump, and then see if we can employ deep learning algorithms or object detection solutions to these problems. So this is an example of our data. So the raw form of our data is the image of JPG format. And then we have a fixed representation of the image. What happens is that each and every pixel is classified according to its location, well, in the X, and then in the X and Y, and then its intensity value on well, inside the cell. So this is important because you can basically work with it in either of the two ways. You can perform object detection or image processing techniques on the first format, and then you can actually perform machine learning methods on the second one, because it actually has an numerical representation per se. So what type of methods did we explore? Well, we basically tried to find a simple way in which we could break it down, and then we basically came up with two ways, which is a machine learning perspective and then perhaps a deep learning perspective. So the machine learning perspective would basically use the FITS format and either cluster the particles of interest, and then the deep learning solution would actually use image processing techniques to either extract the particles that we like, find the shape, find the intensity, such things, find the lines, and then actually either load it into a pre-existing classifier. So what we decided to do is that we tried not to implement a neural network from scratch. We tried to employ transfer learning as to relieve the stress from trying to figure that whole process out. So basically what you see here is the image processing. The first image shows the image processing, the highlighting of the edge of the particles, and then the second one basically is contouring around that particle. So this is where we actually implemented the image processing technique. We identified the single particles, and actually combination of other particles, physically extracted them and then stored them into a directory, so that we could later train a model that can identify if that is one particle, two, if that is a clump or such. And yeah, Smanga will take you through the rest of the process.
Oh, okay. Um, as Mufumi has explained a lot, what we we achieved here, we were able to find the region mean of the background of the image and the region mean of the particles as we were trying to extract the particles from the background, and we will also be able to find the cluster centers as where the centers of the clusters centered of the as where the the clusters of the background and particles, and we were also able to find some relationship between the number of pixels and the particles, as Mufumi showed you a fit file there. Oh, okay. Basically, here we try to apply the k-means algorithm. What we were applying for, we were in an particles in a particle. Firstly, we try to identify the edge of the particles, where the particles edge is. Then afterwards, we try to figure out the peaks of the particles so that we can be sure that okay, these particles ends here and stuff. We also try to use the watermark boundaries for the segmentation, try to detect the distance between the particles, as where we were basically we were trying to figure out how many clumps there are there. If there are no distance in between the particles, then we can basically say that okay, this is the clump. Okay, here we were trying to use the colors in terms of classifying the particles and try to extract them from their background of the image. Most of challenges that we faced here in this project, it was that the data that we were given, it was not labeled, so it was very much difficult to use that data. And we are if maybe the data can be labeled, I think we can achieve more in terms of doing this project. In terms of recommendations, we try to explore deep learning techniques as Mufumi has explained. We also try to use the CNN and also compare the deep learning techniques and modern images processing methods, and also implement if we can recommend that if maybe we can implement the crowdsourcing for data labeling, that might help a lot in terms of finding the clumps and the number of particles per clumps. Hi, my name is Mangaliso Mguni. I'm from Project Kganya from the DST program. Basically, our project was to try and find the clumps in an image and also try to find the number of particles per that clump. We would like to thank DST and CSIR for this amazing opportunity, and also, of course, I would like to thank my colleague Mufumi Rekoto for a fantastic job he done.